My name is Dr. Ibrahim Karume. I work at the Chemistry Department, College of Natural Sciences, Makerere University. I and my research group happen to be one of the lucky winners of the highly competitive Makerere University Research and Innovations Fund awarded in 2019. The project proposal for our work was titled Precious Metal Recovery. Under this, we looked at palladium, platinum, and gold by electronic waste recycling using cyclodextrin from starch extracted from non-edible plants. Our sole objective was to find a way of recovering most important valuable metals found in most of our electronics dumped in our dumping site. Once left there, you may not get the value back, or they may end up leaching into our water stream, polluting the environment and causing problems to our health. Our target was to use cyclodextrin. To a layman, cyclodextrin is an oligosaccharide. It is a simple sugar, a simple cyclic sugar made up of glucose units, 6 glucose units to 8 glucose units in a ring form. And because of the highly negative charge, because of the oxygens in the glucose molecules, you find that these cyclodextrins have the ability to attract, to form electrostatic attractions with metals. And in literature, it has been found that cyclodextrin coordinates very well with some simple metals like lead, copper, and many others. And it was against this background that we envisaged the use of this cyclodextrin to extract more heavier metals, something like gold, platinum, and palladium, which we find in most of our electronics. So we're able to go and collect electronic wastes from dumping sites. Mostly these are found in form of the CPU, motherboards, used in most of the common electronics. The electronic wastes were digested under an acid, and our cyclodextrin was obtained from starch by an enzymatic process. All these were confirmed experimentally by simple reactions which don't require sophisticated setups. We managed to use our cyclodextrin to extract metals of interest from the entire matrix of the electronic waste. And we managed to register above 20% gold from electronic wastes, and over 70% gold was recovered from soil samples containing gold. Okay. Ladies and gentlemen, this proposed approach is environmentally benign, and it should be a much preferred approach compared to methodologies which employ cyanide leaching, which is, very well, cyanide can be very toxic if not handled well. Then we have approaches which use mercury amalgam, which mercury has always found way into our water stream and absorbed by plants, which at the end, if consumed by human beings, tend to accumulate in the body. And we have seen cases of kidney failures, liver failures, carcinogenic effects. Okay, so when you look at this, if we use an environmentally benign approach and we try to promote good health and well-being, and also if this method is further studied on and scaled, we may end up obtaining much of our precious metals back from electronic waste. And this is likely to create employment and income to most of these low earners. So when we look at all this, we are addressing SDGs, which is the sole objective to push our country to the next level. On behalf of my project members and the entire Makerere University, we sincerely thank the government of Uganda for coming up with this initiative. This is the way forward. Funding research is the only way of developing a country at a very fast rate. Thank you so much, Government of Uganda. Thank you so much, Makerere University Research and Innovations Fund, for coordinating this fund. Thank you all.